Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Aurelia Osadi and I'm the moderator of Group 3. Now we are going to present about logical database design and the relational model. We hope you are looking forward to our presentation. Let me introduce my group member first. Our group consists of Ahmad Fauza, Esa Lovena, Beta Handayani, Salsabila Sawageza, and Aldian Feldiansyah. In this chapter, we have 8 learning objectives as you can see. Then, let we start our presentation. For first learning objective will be presented by Esa Lovena.
Okay, thank you, Aurel. So I will be explaining about the first learning objective about the key term relation, primary key, composite key, the foreign key, null entity integrity rule, referential integrity constraint, well-structured relation, anomaly, surrogate primary key, recursive foreign key, normalization, normal form, functional dependency, determinant, candidate key, the first normal form, the second normal form, the partial functional dependency, third the normal form, the transitive dependency, synonym, as or alias, homonym, and enterprise key. Okay, the first explanation about the relation. What is the relation? The relation is a named two-dimensional table of data. Each relation consists of the set of named columns and arbitrary number of unnamed rows. And the second, the primary key. What is the primary key? The primary key is an attribute or the combination of the attribute that uniquely identify each row in a relation. And the number third, the composite key. What is the composite key? The composite key is the primary key that consists or more than one attribute. For example, the primary key for a relation-dependent would likely the consist of the combination MID and dependent name, and therefore the foreign key. The foreign key and the attribute in a relation that serves as the primary key of the another relation in the same database. For example, consider the relation employee 1 and department. Employee 1, MID, name, department name, and salary. And department include the department, department name, location, and the facts. And the number 5, null. What is the null? Null is the value that may be assigned to an attribute when other value apply or when the applicable value is unknown. For example, it is not the same as a numeric 0 or the string of blank. The inclusion of null in the relational model is somewhat controversial because it sometimes leads to anomalous results. And the sixth, entity integrity rule. Entity integrity rule is a rule that states no primary key attribute or the component of the primary key attribute and may be null. And the next is the referential integrity constraint. Referential integrity constraint is a rule that stated that either each foreign key value must match a primary key value in another relation or the foreign key value must be null. And the H well-structured relation. Well-structured relation is a relation that contains minimal redundancy and allows users to insert, modify, and delete the row in a table without error or inconsistency. And the ninth, anomaly. Anomaly is an error or inconsistency that may result when a user attempts to update a table that contains redundant data. The 3 types of anomaly are the insertion, deletion, and the modification anomaly. And the 10, surrogate primary key is a real number or other system assign the primary key for a relation. And the 11, recursive foreign key is a foreign key in a relation that reference that primary key value of the same relation. And the 12, normalization. What is the normalization? Normalization is the process of decomposing relation with the anomaly to produce smaller, well-structured relation. The main goal of normalization is to minimize the data redundancy, simplify the enforcement, make it easy to maintain data, and etc. Okay, number 13, about the normal form. Normal form is a state of relation that required that certain rule regarding relationship between the attribute or the functional dependency are satisfied. And the 14, functional dependency. Functional dependency is the constraint between two attributes in which the value of the one attribute is determined by the value of another attribute. And the 15, determinant. Determinant is the attribute on the left side of the arrow in a functional dependency. And the 16, candidate key. Candidate key is an attribute or combination of attributes that uniquely identify a row in a relation. And the 17, first normal form. First normal form is a relation that has a primary key and in which there are no repeating groups. A primary key has been defined which uniquely identify its row in the relation. In the 18, second normal form. The second normal form is a relation is the firm normal form in which every non-key attribute is the fully functional dependent on the primary key. Okay, the next number 19, partial functional dependency. The partial functional dependency is the functional dependency in which one or more non-key attributes are functionally dependent on part but not all the primary key. For example, attribute Y has the functional dependence on attribute X if only if its X value corresponds to a Y value. And the number 20, chair normal form. The chair normal form is the relation that is second normal form and has no transitive dependency. Thus, there is no transitive dependence on its candidate key. The requirement is to meet all the requirements of the second normal form. And the 21, transitive dependency. The transitive dependency is the functional dependency between the primary key and one or more non-key attributes that are dependent on the primary key via another non-key attribute. For example, a condition where there are three attributes of A, B, C, the conditions are A to B and B to C. Then C is said to be the transitive dependency on the A through B. And the 22, the synonyms. The synonym is the two or more attributes that have different names but the same meanings. And the 23, as or alias, is an alternative name used for an attribute. The point is that we can change the name of the table and the column names according to what we want. The purpose or alias is to shorten and tidy up the description of the table name and the column name in the system database. And 24, the homonym. Homonym is an attribute that may have more than the meaning. For example, the same account may refer to a bank's checking account, saving account, loan account, or the other type account. And Andalas, the enterprise key. The enterprise key is the primary key whose the value is unique across all the relation. And maybe that's all for me. And the next learning objective will be explained by Hani.
Thank you, Esa. The second learning objective will be explained by me, Beta Handani Azhari. The learning objective is about 5 properties of relations. As explained before, relation is a two-dimensional table of data. However, not all tables are relations. Relations have several properties that distinguish them from non-relational table. Here I will be explain the 5 properties of relations. First, each relation or table in a database has a unique name. Second, an entry at the intersection of each row and column is atomic or single-valued. It means that there can be only one value associated with each attribute on a specific row of a table. There will be no multi-value attributes allowed in a relations. It means that columns in a relational table are not repeating groups. The next properties of relation is each row is unique. No two rows in a relation can be identical. There is at least one column or set of columns, the value of which uniquely identify each row in the table. This property guarantees that every row in a relational table is meaningful and that a specific row can be identified by specifying the primary key value. The fourth property of relation is each attribute or column within a table has a unique name. Because the sequence of columns is insignificant, columns must be referenced by name and not by positions. In general, a column name needs to be unique to the table to which it belongs. The last properties of relation is the sequence of columns that we can see from the left to the right is insignificant. It means that the order of the columns in a relation can be changed without changing the meaning or use of the relations. Okay, that's all about the properties of relations. Next, we move to the third learning objective about 2 essential properties of candidate key. Candidate key defined as the minimal set of fields which can uniquely identify each record in a table. It is an attribute or a set of attributes that can act as a primary key for a table to uniquely identify each record in that table. The first essential properties of a candidate key is that there can be more than one candidate key in a relations. The second essential properties of a candidate key is the value of candidate key must be unique, because it is needed to identify a uniquely value in the table. And the candidate key should not have any redundant attributes. For example, in the table below, we can see that it has 3 attributes, EMP ID, EMP number, and EMP name. Here, EMP ID and EMP number will be having a unique values, because the value of the EMP ID and EMP number doesn't have any duplicates. It means that each employee have a different ID and a different number. And then the EMP name can have a duplicate value as more than one employee can have the same name. We can conclude that the EMP ID and EMP number is the candidate key because it doesn't have any redundant attributes. Okay, that's all from me, and then the next learning objective will be explained by Fauza.
Okay, thank you, Hani. The next one I'll deliver about the fourth learning objective and the fifth learning objective. Okay, the fourth learning objective is talking about the first normal form, second normal form, and the third normal form. Okay, before we go to the first normal form, we have to know or go back to normalization. Normalization is a formal process for deciding which attributes should be grouped together in a relation so that all anomalies are removed. And first normal form, second normal form, and the third normal form is a part or step in normalization. Normal form it is mean a state of a relation that requires that certain regarding relationship between attributes or functional dependencies are satisfied. Okay, the first normal form means any multi-value attribute, also called repeating group, have been removed. So there is a single value, possible null, at the intersection of each row and column. Second normal form means any partial functional dependencies have been removed. In example, non-key attributes are identified by the whole primary key. And the last one, the third normal form. Third normal form means any transitive dependencies have been removed. In example, non-key attributes are identified by only the primary key. So we can conclude that the first normal form, second normal form, and the third normal form has a strong relation, and we call it a step in normalization. Okay, and we go next to the fifth learning objective. The fifth learning objective talking about the problem arise when merging relation. Okay, and we have to know first what is merging relation. And in a previous section, we described how to transform EER diagram into relation. This transformation occurs when we take the result of a top-down analysis of data requirements and begin to structure them for implementation in a database. A database analyst must understand the meaning of the data and must be prepared to resolve any problem that may arise in the process. In this section, we describe and briefly illustrate 4 problems that arise in view integration. The first one is synonym, the next one is homonyms, the next one is transitive dependencies, and the last one is supertype or subtype relation. And the first one is synonyms. In some situations, 2 or more attributes may have different names, but the same meaning. And because of that, we can say that homonym is an attribute that may have more than one meaning. Okay, the next one is transitive dependencies. When 2, 3, and F or 3 normal form relation are merged to form a single relation, transitive dependencies might result. And the last one is supertype or subtype relationships. Supertype or subtype relationship means this relationship may be hidden in user views or relation. So there are 4 problems arise when merging relation. The first one is homonyms, the next one is synonyms, the next one is transitive dependencies, and the last one is supertype or subtype relationship. Okay, that's all of me, and the next learning objective will be delivered by Aldian Feldiansa.
Okay, my name is Aldian Feldiansa. I will present about transforming ER or EER diagram into logically equivalent set of relation. The first one is map simple regular entities. Each regular entity type in ER diagram is transformed into relation. The name given the relation is generally the same as the entity type. Each simple attribute of the entity type becomes an attribute of the relation. Choose one of the key as primary key of the relation. Map composite attribute. When regular entity type has a composite attribute, only the simple component attribute of the composite attribute are included in the new relation. Map multi-value attribute. When regular entity type contain multi-value attribute, 2 new relations rather than 1 are created. The first relation contains all of the attributes of the entity type except the multi-value attribute. The second relation contains 2 sets of attributes, the primary key from the first relation, which become a foreign key on the second relation. Multi-value attribute itself. The primary key of the second relation is the combination of all attributes. The name of the second relation should capture the meaning of the multi-value attribute. Next, map binary one-many relationship. Create a relation of each the 2 entity type participating in the relationship. Include the primary key attribute or attribute of the entity on the one side of the relationship as foreign key in the relation. There is one of many sides the relationship. Map binary many relationship. Suppose that there is binary relationship between 2 entities, type A, type A and B. For such relationship, create a new relation C. Include as a foreign key attribute in the C primary key for each of 2 participating entity type. This attribute becomes the primary key of the C. Any attribute that associated with the relationship are included with the relation C. Next, map binary one relationship. Relationship can be viewed as a special case. The process of mapping such relationship to relation requires 2 steps. The first, 2 relations are created. one for each participating entity type. Second, the primary key one of the relation include as foreign key in the other relation. Next, map unary one-many relationship. The entity type in the unary relationship is mapped into relation using the procedure described before. Then foreign key attribute is added within the same relation that reference the primary key value. Note that foreign key attribute name should reflect the role name on the one side. A recursive foreign key is foreign key in relation that reference the primary key value of the same relation. Map unary many relationship. With this type of relationship, two relations are created, one to present the entity type in the relationship, and then other one, associative relation, to represent relationship itself. The primary key of the associative relation consists of two parts. Take their value from the primary key of the other relation. Any attribute the relationship is include the associative relation. Map weak entities. For each weak entity type, create new relation and include of all the simple attribute as attribute of this relation. Then, include the primary key of the owner relation is foreign key. The primary key of the new relation is the combination of this primary key of the owner and the partial key of the weak entity type. This is sample result. The relation for the weak entity not only has the attribute of itself, but also the key attribute of the other entity set. Do not construct a relation double diamond relationship. Next, map ternary and array relationship. It's recommended that you convert the ternary relationship to a number of binary relationship, and then transform the diagram into relationship. This is sample result. Map supertype subtype relationship. The relational data model does not yet directly support subtype relationship. There are various strategies that database designer can use to represent this relationship. In this lecture, we introduce the most commonly employed strategy. Mapping strategy. Create a spread relation for the supertype and for each of its subtype. Assign the relation created for the supertype the attribute that are common to all members of the supertype, include the primary key, and assign the relation for each subtype primary key for supertype, and this primary key is also foreign key that reference the primary key in relation representing the supertype. Assign to the relation for each subtype the attribute that are unique to the subtype. Map categorize. The problem is multiple supertype may have different primary key. And what the solution? The concept of surrogate key, a specify new key attribute for the subtype. And then this is sample of map categorize.
Relational tables that incorporate entity integrity and referential integrity constraint. Relational model concept. Relational model can represent as a table with columns and rows. Each row is known as a tuple. Each tuple of the column has a name or attribute. Entity integrity. The entity integrity constraint state the primary key value cannot be null. This is because the primary key value is used to identify individual rows in the relation, and if the primary key has no value, then we can't identify those rows. A table can contain a null value other than the primary key field. Referential integrity constraint. A referential constraint is the rule that the non-null value of a parent key are valid only if they also appear as a value of a parent key. The table that contains the parent key is called the parent table of the referential constraint, and the table that contains the foreign key is a dependent tab of the table. Step to create relational tables that incorporate entity integrity and referential integrity constraints. First, define the purpose of the database. Gather the requirement and define the objective of your database. Drafting out the sample input forms, queries, and reports often helps. Next, gather data, organize in a table, and specify the primary key. Once we have decided on the purpose of the database, gather the data that are needed to be stored in the database. Divide the data into subject-based table. Choose one column or a few columns as the so-called the primary key, which uniquely identify each of the rows. Third, create a relationship among tables. A database consisting of independent and unrelated tables serve little purpose. We may consider to use a spreadsheet instead. The power of relational tables lies in the relationship that can be defined between tables. The most crucial aspect in designing a relational database is to identify the relationship among tables. The type of relationship include one-to-many, many-to-many, one-to-one. Fourth, refine and normalize design. For example, adding more columns, create a new table for optional data using one-to-one relationship, split a large table into two smaller tables, and others. The next learning objective will be explained by Geza.
Okay, thank you, Oral. I will explain the last learning objective. It's about use normalization to decompose relation with anomalies into well-structured relation. First, I will talk about what is data normalization. Data normalization is formal process of decomposing relation with anomalies to produce smaller, well-structured and stable relation. And also, data normalization is primarily a tool to validate and improve a logical design so that it satisfies certain constraints that avoid unnecessary duplication of data. Next, I will talk about well-structured relation. Well-structured relation is a relation that contains minimal data redundancy and allows user to insert, delete, and update rows without causing data inconsistency. Next goal is to avoid or minimize anomalies. There are three anomalies. First, insertion or adding new rows force user to create duplicate data. Next is deletion anomaly or deleting a row may cause loss of other data representing completely different facts. And last is modification anomalies or changing data in a row force change to other rows because of duplication. There is example and the anomalies in this table. First, insertion. The insertion is can enter a new employee without having the employee take a class. Next, deletion. If we remove employee 140, we lose information about the existence of a text class information. And last, modification is giving a salary increase to employee 100 force us to update multiple records. Next, functional dependencies. Functional dependencies is the value of one attribute determines the value of another attribute. A to B reads attribute B is functionally dependent on A. A to B means if two rows have same value of A, they necessarily have same value of B. Functional dependencies are determined by semantics. Or you can say that just by looking at data, but can say whether it does not exist by looking at data. There are some steps in normalization and we will discuss after this. Next, first normal form consists of only atomic attributes. A primary key has been identified. and every relation is in first normal form by definition. Next is second normal form. Data consists of first normal form and no partial dependencies. A partial dependency is when a non-K attribute depends on part of the primary K, and of course you need a composite primary K. Last is third normal form. Data consists of second normal form and no transitive dependencies. And a transitive dependency is when a non-K attribute depends on another non-K.
That's all from our group. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.